Welcome to section 1.4. We're going to be talking about functions. Now, when we talk about a relation, it's a pairing of an input value to an output value. So all of these are going to be relations, but not all of them will be functions. A function is a special type of relation where each input value has exactly one output value. Now, when we talk about the inputs, whether for a relation or a function, that's our domain, the x values. That's our independent variable. The range is our output values, our y, our dependent variable. We can represent functions in multiple different ways, verbally, like writing a sentence or talking about how the input and output are related, numerically, maybe a table or ordered pairs, graphically, and algebraically, where you write an equation in two variables. Now, testing for functions algebraically, that's when we determine whether y is a function of x. We try to solve for y in terms of x. So now, in problem number 1, does the table describe y as a function of x? So if we look at y as a function of x, we want to look, does each input value, x, have one output value? And if you look at the input values of 1, it has an output of 1 and an output of 3. So because of that different outputs, no, it's not a function. Next, we're going to determine if y is a function of x. So we're going to solve for y. So to solve for y, we're going to take the square root of both sides. So y, So for problem number 2 and on, we're going to determine whether the equation represents y as a function of x. So let's rewrite this, just y equals x squared. So yes, y is a function of x. Yes. For number 3, we're going to get y by itself so we can subtract x squared from both sides. Y equals 1 minus x squared. So yes, y is a function of x. Now if we go to problem number 4, once again, let's get y by itself. So add x to both sides. Y squared equals 1 plus x. And now let's take the square root. So y equals. When we're solving by square roots, we get two solutions, the positive solution and the negative solution. So the plus or minus, the square root of 1 plus x. And that plus or minus there messes us up. So no, y is not a function of x, and it's all because of that plus or minus. Number 5, subtract x squared from both sides. Y squared equals 8 minus x squared. Take the square root of both sides, y equals. Once again, taking the square root plus or minus the square root, 8 minus x squared. Because of that plus or minus, once again, no. Y is not a function of x. On the next page, function notation. When we talk about function notation, we're using f of x in place of y. And that's how we read that, f of x. Now it could be a g of x, an h of x, a k of x, it doesn't matter. It's just that notation. And what's nice about function notation, f of x, let's say equals 1 minus x squared. So let's say if we had f of 2, it's 1 minus 4, which is negative 3. What's nice about function notation is our input is in parentheses, and our output is on the outside. It gives us our input and output all in one statement. Next, we're going to talk about evaluating what's called a piecewise function. And a piecewise function is defined by two or more equations over a specified domain. So if we look at problem number 1, we have two equations. We have the x squared plus 1 and the x squared minus 1. So what we want to do is we want to look at our inputs and decide which of the equations we use. So for f of negative 1, the top one is for when x is less than 0. Since negative 1 is less than 0, we're going to use that x squared plus 1, the top one. So it's negative 1 squared plus 1. So f of negative 1 equals, negative 1 squared is 1 plus 1. So f of negative 1 equals 2. Now we're looking when x is 0. So f of 0. So the top one, x is less than 0, and the bottom one, x is greater than or equal to 0. Since 0 equals 0, we're going to use the bottom equation this time. So it's going to be 0 minus 1. So f of 0 equals negative 1. There's our second. So we use our input to determine which equation we're going to use. And then for f of 1. So 1 is greater than 0, so we're going to use the bottom equation once again. So 1 minus 1, so f of 1 equals 0. Looking at another example. Here we have 3 equations. So f of 0. Now 0 is less than 2, so we're going to use the top one. So it's x squared plus 3, so 0 squared plus 3. So f of 0 equals 3. For f of 3. Now, 3 is not less than 2, so we can't use that one. And for the second one, it's saying when x is between 2 and 4. Since 3 is between 2 and 4, we're going to use that. Now, this is just a constant. So when x equals 3, or anything between 2 and 4, including 2 and 4, our output is going to be 7. So there's really nothing to do there because the output is just a constant. And then for f of 5, what we have here is we want to look, well, x is greater than 4, 5 is greater than 4, so we're going to use the last equation. So it's going to be 2 times 5 minus 1. So it's 10 minus 1, so f of 5 equals 9. Another example for a piecewise function. Here we once again have 3 equations. So for f of negative 2, we want to look to see where negative 2 would fit. So x is less than negative 1. Negative 2 is less than 1, so we're going to use the top equation. So it's 2 times negative 2 cubed plus 3. So it's going to be 2. Negative 2 cubed, negative 2 times negative 2 times negative 2 is negative 8 plus 3. 2 times negative 8 is negative 16 plus 3, so f of negative 2 is going to be negative 13. For f of 0. Once again, look to see which one 0 would rely on. 0 is not less than negative 1, but 0 is between negative 1 and 5, so we're going to use the middle equation this time, and that just says f of x equals 12 or y equals 12. So that's it. F of 0 equals 12. It's just a constant. And then for f of 7. Once again, look to see, not there, but 7 is greater than 5, so we're going to use the third equation. And that's going to be the opposite of 7 squared minus 1. So f of 7 equals the opposite of 7 squared, which is 49, minus 1. So f of 7 equals negative 50. And that's how we can evaluate piecewise functions. For problem number 9, we're going to find the real values of x such that f of x equals 0. So what we're going to do is we're going to replace f of x with 0. So 0 equals 12 minus x squared over 5. Now what we can do to solve this is put 0 over 1. We have a proportion and we can cross multiply. 5 times 0 is 0. 1 times 12 minus x squared is 12 minus x squared. we can solve this equation by adding x squared to both sides. X squared equals 12, and now to solve, take the square root of both sides. So x equals, solving by square roots, two solutions, so plus or minus. And we're going to simplify the square root of 12. Square root of 12 is the square root of 4 times the square root of 3, which is 2 square root of 3. And there is our solutions. Plus or minus 2 root 3. Number 10 is similar. We're going to put 0 in for f of x. X squared minus 8x plus 15. We can actually factor this quadratic. X and x. So to multiply to 15 and add to negative 8, we need a negative 5 and a negative 3. Now we set each factor equal to 0. X minus 5 equals 0. X minus 3 equals 0. So x equals 5. X equals 3. And there are our two solutions. Those are the values for x that make that function equal to 0. On the next page, the values of x that make f of x equal to g of x. So what we're going to do is we're going to set them equal to each other. So x to the fourth minus 2x squared equals 2x squared. In order to solve this polynomial, we're going to get the equation equal to 0. We're going to subtract 2x squared from both sides. So we get x to the fourth minus 4x squared equals 0. Now, the greatest common factor of those two terms is x squared. So we factor out the x squared. Remember, you're dividing by x squared. X to the fourth divided by x squared is x squared. Negative 4x squared divided by x squared is negative 4. We can keep factoring x squared. And then when you factor x squared minus 4, you get x plus 2, x minus 2. Now that it's fully factored, set each factor equal to 0. X squared equals 0, x plus 2 equals 0, x minus 2 equals 0. Take the square root of both sides, x equals 0. Then you get x equals negative 2 and x equals positive 2. Now we could go in and check these. 0 to the fourth minus 2 times 0 squared is 0. 2 times 0 squared is 0. So that one works. Negative 2 to the fourth is 16 minus 2 times negative 2 squared. So it's 16 minus 8, which is 8. 2 times negative 2 squared is 8. So you get 8 equals 8. That worked. When x is 2, 2 to the fourth is 16 minus 2 times 2 squared. So 16 minus 8 once again is 8. And then 2 times 2 squared is 8. So that worked for all three. So all three of those are valid solutions. Problem number 12 is a much more complicated problem. So what we're going to do is we're going to set them equal to each other. The square root of x minus 4 equals 2 minus x. We did solve some questions like this last year in Algebra 1. Now what we're going to do is we're going to isolate the square root. We're going to add 4 to both sides. Excuse me, it was Algebra 2. Square root of x equals 6 minus x. Now, we want to get rid of the square root. So to do that, we're going to square both sides. Not everything, but both sides. And notice how I put my grouping symbols around my 6 minus x. So we get x equals. Now, when you square 6 minus x, it's 6 minus x times 6 minus x. So when you multiply, you get 36 minus 6x minus 6x plus x squared, which when you rewrite is x squared minus 12x plus 36. So be very careful when you square those binomials. Now we want to get it equal to 0. You subtract x from both sides. 0 equals x squared minus 13x plus 36. And we can factor that. When we factor, we get x and x. Now the multiplied at 36 and add to negative 13, you get a negative 9 and a negative 4. So when we set those equal to 0, you get x equals 9 and x equals 4. Now let's check. I'm going to write this one out. So I'm going to check the 4 first. The square root of x, so 4 minus 4 equals 2 minus 4. So the square root of 4 is 2 minus 4 equals 2 minus 4. Negative 2 equals negative 2. That's a true statement. The 4 is good. Now the 9. The square root of 9 minus 4 equals 2 minus 9. The square root of 9 is 3 minus 4. 2 minus 9 is negative 7. We get negative 1 equals negative 7. That's not a true statement. That didn't work. So 9 is not a valid solution. It's what we call an extraneous solution. Because it's an extraneous solution, it's an apparent solution that doesn't work, so x equals 4 is our only valid solution. In the next video, we'll be talking about interval notation. Thank you.